So before we go on to our example, we have here the theorem 9.14, the alternating series test. Let a sub n is greater than 0. The alternating series, the summation from n is equals to 0 to infinite of negative 1 to the power of n a sub n, and the summation from n to 0 to infinite negative 1 to the power of n plus 1 a sub n converge when two conditions listed below are met. So the two conditions are, first, the limit a sub n as n approaches to infinite must be equal to 0. Second, a sub n plus 1 must be less than or equal to a sub n for all n. For the alternating series remainder, for a convergent alternating series, the partial sum, or the S sub n, can be useful approximation for the sum S of the series. The error involved in using S approaches to S sub n is the remainder. R sub n is equals to S minus S sub n. So the theorem 9.15, which is the alternating series remainder, if a convergent alternating series satisfies the condition a sub n plus 1 is less than or equal to a sub n, then the absolute value of the remainder, which is the R sub n, involved in approximating the sum S by S sub n, is less than or equal to the first neglected term, that is, the absolute value of S minus S sub n is equals to the absolute value of R sub n is less than or equal to A sub n plus 1. So this theorem of the alternating series remainder is useful when the second condition of the alternating series is satisfied.
So we have here the example. The summation from n is equals to 1 to infinite of negative 1 to the power of n times n over ln n plus 1. So let an is equals to n over ln n plus 1. So let na to, or direct substitution na to si limit, which is n approaches to infinite. So we have here this direct substitution na nato, then we get an indeterminate. So since indeterminate man siya, let's use the L'Hopital's rule. So from an, we're gonna convert it to the function f of x. So f of x is equals to n over ln n plus 1. So we have here x over ln x plus 1. So ilimit na to siya. Limit of the first derivative of f of x as x approaches to infinite. So limit ang the derivative of x, we have 1, and the derivative of ln x plus 1 is we have 1 over x plus 1. So i-simplify lang nato na siya. So we have here the limit as x approaches to infinite, 1 times x plus 1 over 1. So we have here the limit as limit of x plus 1 as x approaches to infinite. So i-substitute na to si limit. So we have here infinite plus 1, so is equals to infinite. So since limit of an as n approaches to infinite is infinite, by alternating series, thus the series is divergent. So mag-convergent lang siya if katong condition sa alternating series test is satisfied.
And that's all for the alternating series test.